Morning. My name is Carrie Shuster. I work with Florida Power and Light, part of NextEra Energy. I'm a lead project manager, and we're integrating a lot of what we're hearing today in our work processes and flows. So we're going to get into a little bit about what we are doing with the data. This is a Taros drone that FP&L does have. We don't have it in the air just yet, but we plan to utilize that in the near future. So NextEra Energy is the world's #1 producer of renewable energy in the world, right? We were named one of the world's most ethical companies 14 times. We have a large footprint, not only in Florida, but across the United States and into Canada as well. I'm particularly with the Vegetation Management Department. Our Vegetation Management Department is responsible for the inspection and maintenance of utility lines in 47 states and in 4 provinces of Canada. We have tens of thousands of overhead distribution and transmission lines that our folks are out there inspecting and maintaining. Particularly in Florida, we are the largest utility in Florida. We serve about 5.7 million customers with about 800 substations. Just to touch a little bit about what Tim was mentioning earlier with the Perceptos drones, we deployed Perceptos at our substations now, right? So we're ramping up, but it's really good to have that Perceptos, the drone in the box at different substations for a quick visual of what's going on, particularly after storms. And if we need to get some quick eyes in the sky, that's the way we're able to do that. So with line clearing, tree trimming, and utility line clearing, Florida's a little bit different. We live in a subtropical area. The trees grow year-round. We don't normally have a dormant season for most of our vegetation. I am a certified arborist as well, so I've been with the Vegetation Department going on for about 17 years, and there hasn't been a lot of innovation, particularly in the line clearing space, right? Climbing trees, hand saws, ropes. We moved into the space of bucket trucks. We do have, we are testing equipment now with remote controlled operated trucks now in our system. But primarily the future for our department and our system is really AI modeling, predictive growth, drones, capturing imagery. And like what we were talking about earlier, what do we do with it? What do we do with the imagery we have? So ultimately, we've been on a journey over the last year, and even more than that, actually, the year and a half, to transform our business model with vegetation management. Our historical approach is really manual inspections, labor-intensive, paper-based maps, very subjective inspections, random quality checks, and we're paying by the average cost per mile. It was very difficult to understand what is the work we have out there? What is the scope we have in the areas we have? So we've been moving more towards an intelligent line clearing trim cycle. We have, with the use of GE's visual intelligence platform, we have been able to get into a space where we understand the work scope, automated work designs, and we're going to use that information for predictive growth modeling and change detection. We've been on a journey over the last couple of years to transform our business model. Using LiDAR is not the first step in the journey. We first were able to make a difference with our processes using aerial and satellite imagery. We'll talk a little bit more about that. That did change from our legacy systems into our current process and where we're moving into over the next few months. So again, from 1992 to about 2018, we're all paper. You can see down here on the left, that's a manual inspection that we have. It was not unusual for these papers. And remember when I said we have tens of thousands of overhead lines being inspected each year? This is the result in which that would come. A lot of highlights, a lot of tick marks, a lot of comments on there. And what do you do with that? It's very subjective. Then in about 2019, we moved to our electronic inventory. We moved to a paperless workflow system at that point with work management. We were able to use satellite and aerial imagery to understand where we think vegetation is, but we didn't have a lot of information about the vegetation that was in that area. It did move us in the right direction, and it prepared us for the next step in what we're taking in our journey now. So we have a GIS inventory. We were able to capture the satellite and aerial imagery, understand where we feel vegetation is, have inspectors go out there and validate the information, and essentially get it paperless onto our crews in the field to execute the work. But the future, which we're in now, which we're stepping into now, is optimized, lean, and smart. We have a lot of different imagery being collected in Florida Power and Light and NextEra. We have access to a lot of different data, not only for the use of vegetation management, for pole inspections, asset inspections, right? So we are now in a space where we are accessing that data and seeing how we can use it for vegetation management purposes. We have been using the GE digital platform, Visual Intelligence. We'll get into that a little bit more. So we then take the collected data and we process it through the Visual Intelligence platform, which creates a 3D twin of our electrical infrastructure, as well as designs the work that will be executed in the field. So we have an automated work design, if you will, that now we don't have to create from scratch, we validate, and we can look by exceptions. From there, we will feed that work scope into our work management system. We have optimization of scheduling and execution, and we're going to use that data for our future predictive modeling. Inside the Visual Intelligence platform, we also have our electric network model. We have this GIS visualization of our assets in the field, right? Our overhead power lines, our transformers, our assets that we need in order to understand and overlay with the imagery collected. So we did a statewide sweep recently. In the fourth quarter of last year, we had a statewide sweep. We are among the first utilities going into the distribution space with LiDAR and using it down to distribution, down to the feeder and neighborhood lines, in the neighborhood lines that serve customers' homes. Typically, the space is usually for the larger transmission lines, right? So we are now going in. We just did a statewide sweep, all of our distribution and transmission lines in the fourth quarter of last year. We created the digital twin using Visual Intelligence. We were able, Visual Intelligence does automatically classify the information, so we are able to understand poles, wires, buildings, ground, and vegetation as well. So from there, we were able to understand encroachment, the vegetation encroachment on the overhead conductors, focusing mainly on feeder lines. So you can see on the right here, those colors that you see, we were able to configure and work with GE to determine where do we have areas where the vegetation is too close to the power line. So now we're able to know how much vegetation is there, where it's at, and how close it is to the line. Before we were able, with satellite and aerial imagery, we're really only able to understand, we think vegetation is in this area, but now we have a lot more information to make just smarter business decisions. We are taking the data that we're collecting, the output from the Visual Intelligence platform, and we are updating our GIS inventory as well. We did have some lessons learned, right, from the statewide sweep. As we heard earlier, collecting the data in the right way is imperative, right? So we had to go back a few times to make sure we had absolute accuracy instead of relative accuracy, because we want to use this data for growth modeling, predictive analysis, to understand not only what do we have out there now, but what is it that we need to trim, and where is this locate? What are the growth rates in certain areas, so we can get ahead of where we feel the work would be to help us with our business forecasting. Not only do we have the 3D viewer in visual intelligence, but we also have 2D polygons. In addition, the platform automatically creates our work zones. We have work zones there in red, and we configured them using in partnership with GE to understand how our crews execute their work. So these work zones are essentially unit-based designs. So we now know how many work zones, how many setups our crew will need to execute the work. The colors there are based on the distance from the line. You can see little boxes there with colors. Red would mean it's anywhere from 0 to 4 feet away from the overhead primary. And then subsequent colors are the feet out from there. We work through classifications again, right? We talk about collecting the data, then the specs in which you collect it. We've learned through this process is very, very important. Working through misclassifications, the way the data was collected as well, and working through noise, if you will. I mentioned that from the collect, we have this detailed work scope. So now we're able to determine not only where the work is, what the work is, but how much is there as well. And this is driving our transformation of our current contract constructs. We're using this information to renegotiate our current contracts and unit-based pricing instead of cost per mile, where there may be work or may not be work in that mile. This is an example of work execution. To the left-hand side, you can see you have some red areas. Let me see if I get this pointer right. Right here, you can see there's vegetation and the power lines, and you can see we have encroachment within 0 to 4 feet of the overhead primary. We're then able to use drones, and I'll talk a little bit about that, to do automated quality inspections. So not only are we using the baseline information for the statewide collect and all the other collects that we have access to, but once the vendor turns in the work as completed, we are deploying drones throughout the system to fly the job area again, putting it through visual intelligence and doing an automated quality assurance assessment. So visual intelligence will actually understand the collect dates. It's integrated as well. It's receiving information back from our work management system to understand when the work is completed, and the next flight, if it's within a certain number of days, it will consider it a quality check, and it will compare and let you know where we feel potential rework items are. So you can see there they were able to clear the vegetation that was close. So we will set the parameters in the platform, what's an acceptable level of footage, and determine then the platform will automatically spit out where we think rework is. Same down here. We had some imagery of before and after the work was executed. We have a lot of palm trees down here in South Florida. It's very hard to keep them out of the power lines because of how fast they grow. Their fronds will be back in the power lines within a few months. So we are able to, and this is an example of the before and after from a palm tree in the overhead power line. Obviously, we can leverage this data to monitor compliance, right? We're able to extract all the data from not only where we feel the volume of work is, but also the execution rate and the distance of conductors. So all of this is going to be used for the next step in our journey, which is true automation and predictive analysis, so we can understand and forecast and changes with the rain, right? Overlaying different information and really using data science to propel the program to really provide value for our customers. So our next steps, we talked about this, which is tree segmentation. So right now, we understand from a polygon lines or grouping of trees, but we really want to get down to the actual tree segmented itself. And we want to know the growth of that specific tree versus a clump of trees or an area of trees. All of this would be used for storm response. We are leveraging the data to understand specifically with change detection before and after storms. And then having this platform that can take the data collected and process it to this level really helps us understand where the areas of work is needed and where to deploy resources. That's it.